Hello, guys. Good afternoon from everyone. Everybody, we are waiting a little, a few minutes, people to arrive. We can, let's say, 3-4 minutes here. Marco is just arrived. Marco was in another conference. It was in Africa, Marco. It was for the United Nations. No,
No. This was the TinyML Foundation meeting.
Okay.
They have something which is called TinyML for Good.
Mm-hmm.
And they have ARM and C. They're all part of this initiative.
Okay.
It was quite interesting. Quite interesting.
Okay.
I think the most interesting news is this microbit. I don't know if it is popular in Brazil. It is
microbit.
Okay.
Yes, microbit. Yeah.
So the new version, the version 2, they added a microphone and it's much more powerful. Perfect. And so apparently they are going to port TinyML on the microbit, which would be quite nice.
No, yes. Well, microbit I think it was very good, and in fact, what they did with microbit in UK was fantastic. I think I heard that a lot of, including the number of women that went to technology or went to engineering schools, rocket in UK because the program that they started during the high school using microbit. So
wow, interesting.
No, yes, it was fun. Was a BBC? I think BBC paid for this project. Was it?
Yeah, exactly. I wanted to say, I think it's a nice example where the government actually, helps, right? So it's a startup, but it started with the government money. So, yeah, but it's good.
Okay, Marco. Well, besides, let me tell you a little bit about what we have here. We have it's a mix of people here. We have people from Itajubá. Itajubá is a city that belongs to a Minas Gerais state. Is a state. Let's say it's like if you think about a triangle, you have São Paulo is in the coastline, more or less the coastline. You have Rio de Janeiro, and you are talking about this state is a 300 kilometers more or less, or this Itajubá is something like 300-400 kilometers from São Paulo or Rio, let's say. It's the second biggest state in Brazil, and they are a very important state in with farms and so on. And nowadays, in the Itajubá region, is the south of the state. They are having a lot of new startups. Focus in IoT, telecommunications, and new technologies. So it's very interesting. It's a very, very interesting area. So we have people from Itajubá, and also we have people from São Paulo, from IESTP, the Instituto Federal de Educação in São Paulo. We have João Shinohara and a lot of other guys here, some professors and some students. They have mainly from 3 cities. São Paulo, the main city, São José dos Campos, where Embraer is located. They are the aeronautical company, and also Guarulhos, when the main Brazilian airport are located.
Wow!
So they are people from those 3 cities, plus Itajubá, and me here lost in Santiago.
and the main. I mean, the main contact. What is the main contact?
Where you mean?
I mean, they come from different places because they're following the courses online.
In fact, no, because people from in IFSP they don't have one single campus. It's several campus, several campi. No, it's a campi with several campus. No, it's around the state. So they have much more than that. I think, I don't know, João, if you can talk about a little bit. I think it's several campus, no?
38 campus.
How much?
38.
38. Yes,
wow.
30.
Wow.
Yeah. In fact, in the past, Marco, was a technical school, schools that became engineering schools, so they made a collection of all of that in a institute, a kind of a university. So it's a technological university. The focus is technology.
Technology, okay.
Yeah, perfect. Well, Marco, I think that I think that you have 5 minutes after our time. I leave the floor for you. thanks a lot. I leave for you to make the presentations. I think you
Sure.
Thanks a lot.
Thank you very much for the invitation. Really a pleasure to be here. And if you agree, I mean, if you have any question, please post it in the chat. I have that open, so we make it more, discussion than a lecture. So let me see if I get the pronunciation. Is it hola? Hola. Okay. Yeah. I'm Marco. I'm a research scientist in a place called ISTP. I will tell you a bit more about ISTP in the next slides. I studied at KTH in Stockholm. So my interest was studying what is called ICT for development. So how can ICT be used in developing countries? And KTH, which is the Technical University in Stockholm, had the only course in ICT4D. So I got my PhD from there. I coordinate a unit which is called Science, Technology, and Innovation. So it's using technology to do science in an innovative way. And I work with the ITU, which is the UN agency for telecommunications. And I like Japan, so I found out how to become a visiting professor in Japan, and I go there a couple of times every year. That was before COVID, unfortunately. So just a short note about ICTP. So the name is International Center for Theoretical Physics. It was founded in '64 by this person called Abdul Salam. He later got the Nobel Prize in Physics, so the first Pakistani and the first Muslim to receive a Nobel Prize. And he was, of course, super bright. He was the brightest student in Pakistan. He studied in the UK, but then he went back to Pakistan and found out that he felt isolated. So at that time, you couldn't get a paper. You had to request a paper by letter. So he decided to set up a center where scientists from developing countries and for developed countries can work together. And at that time, my place, Trieste, which is the northeastern part of Italy, was on the boundary between the Eastern Bloc and the Western Bloc. So this was the only place where people from Russia and from the US could write a paper together. And we had people from, Iran and from the US, from India and Pakistan. So they all come here and they work on physics together. And the motto is that scientific thought is the common heritage of mankind. So you can have different religions, different languages, different political views, but if you're talking about equations or, Python or, wireless, you're talking the same language. So it's quite interesting. So we have many activities. So the way the center works is that people come here and they spend some time at ICTP, ranging from, 1 week for a workshop up to, 6 months or 1 year if you are a student. So we have many activities. There's more than one per week in many different fields. So high energy physics, condensed matter, kind of theoretical fields, plus my group, which is, again, applied physics or STI, we also organize about 10 activities every year. And people coming to ICTP, they come from all over the world. So this is not at all a center for developing countries. It is a center where people from all over the world meet. And here you have some statistics. So you see it's really a mix of people coming from all over the place. More than 120,000 people came here in the last 50 years from all over the place, 188 countries. So even from the remote island in the Pacific, we had some people coming to ICTP. I asked some slides about Brazil because we had some visitor from Brazil that I will tell you about. And here are the numbers. So this tells you that I would say on average we have about 100 people coming from Brazil, coming to ICTP every year. And in total, it was more than 4,000 that came in the last 50 years. And ICTP has different programs. So there's something which is called affiliated centers. So a university that wants to work with ICTP, they apply and they become an affiliated center. They get a budget and they can send people to ICTP, students or professors. We have what is called associate members. This is something that Salam invented. And he said that it was a way for people to come here and recharge the batteries. So we all know that when you're working, you have a lot of administrative things to do. You have to lecture. So he said, if you come to ICTP for couple of months, you can only carry out research. And so you recharge the batteries in some way. And then we have what is called TRIL fellows, that are students or even professors that come to ICTP to visit a lab. So they want to work in a specific lab, like my lab, which has to do with tiny machine learning and IoT. They can come here and spend a couple of months, at ICTP. Those are all funded projects. So if you get a TRIL fellowship, then ICTP will pay your salary, your travel, and so on. And then for PhD students, we have what is called STEP fellows. So that is what is called a sandwich program. So they may, study in Brazil, but they come here 3 months every year to work in the labs, and then they go back to Brazil, and the next year they come back here again. And in fact, we just had a STEP fellow from Brazil working in GPS research. So we had few. They see the number is really low because, of course, Brazil is really good in research. But I think it's an interesting project. And I said that I have these statistics because just a couple of months ago we had a delegation from Brazil. You might recognize some familiar faces. They came here to visit ICTP for the G20 meeting that was held in Trieste. Brazil was also really important in the history of ICTP. In fact, we had Jacob Pallis was the chairman of the scientific council. So the council that decides the research that should be done at ICTP. This is a very high level council, and he's from Brazil. And now we have Carlos Alberto de Carvalho. Since 2013, he's a mathematician, and I met him many times at ICTP. So Brazil is key, at ICTP. This was the main point. And in fact, in 2012, we opened a regional branch in Sao Paulo. This is a Center for Theoretical Physics, and they call it fundamental research, but I can tell you they also do some applied research there. And so we can organize easily activities in Brazil in this safer. So if you have something in mind, that is a really good place to organize activities. Okay, that is all about Brazil. So about my group. So my research group is a bit peculiar compared to other kind of traditional research groups, because we say that we have 3 pillars. So research is one. So we publish papers. We're evaluated at the end of the year by the number of papers and level of the papers we publish. But we also like to deploy stuff. So we like to deploy stuff, especially in developing countries, to test new technologies. And we believe that this is very useful for the training part as well. So we like to, give the training on new research. So you need to carry out research so that you give some good training courses. But for the training, it's also good to deploy stuff. So we believe that these 3 pillars, they really work together, and it's quite challenging to keep them balanced, but that is how we, work, and it's, I think, quite peculiar for a research group. In fact, I, pulled out some pictures just to show you the kind of activities that we carry out while publishing papers. And this was something that we did for many years, that was teaching wireless communications using oil cans. So something that is really cheap, you can find in each and every country, can be used as an antenna. But the goal was not using it as a real antenna and, in a deployment, but teaching people that you can learn about antennas by doing hands-on activities. So you see there's people drilling holes in these cans, and then, putting a small, active part in the antenna, and then we used to measure the performance of these antennas in the field. So it's, as you see, very hands-on. We, deployed many networks all over the place. Those are pictures from a remote island in the Pacific Ocean called Chuuk in Micronesia. And it was about setting up a long Wi-Fi link to connect this remote island to another bit bigger island. So, working with communities and trying to learn from them what is needed and what is useful. And finally, we worked for many years in what is called TV white space. which is about the use of spectrum all over the place. And this picture comes from the Galapagos Island. You can spot there's a small turtle on the background there, and then Darwin Foundation. So we measure the spectrum in really remote places as well. And finally, this is a picture about a deployment we did in Malawi. So connecting hospitals and universities to provide internet connectivity, because even now as we speak, half of the world is not connected to the internet. So there's a lot, to be done in that field as well. Okay, getting back to IoT, which I guess is what you're interested in. So IoT and development. There's a website, I don't know if you know this, which is called Thinkful.net. It's quite interesting. It's kind of a Google for IoT devices that publish data openly on the internet. So this site will show you IoT devices that are publicly available on the internet. So those are, weather stations, buoys, air quality sensors, bike rental, offices. And so, of course, if you have your private network, it will not pop up in Thinkful. But it's quite interesting because there's many of these, public IoT networks. In fact, you see there's many of them in the sea. And those are buoys, ocean buoys that send information about the ocean publicly on the internet. And the point of this picture is that there's places like, I'm zooming into Europe, that are completely covered by sensors. People often don't, are not aware of that, but in most places you have lots of information about air quality, weather stations, and you name it. We're living a data-rich world. But there's other places, and I'm focusing on sub-Saharan Africa here, where there's not as many sensors. And if you think about the applications and the size of the African continent, many people would benefit from having more information. And in fact, this is just one example, which is about weather stations. So if you look at weather stations in the world, there is the same number of weather stations in Africa as there are in Germany, while Africa has 1.2 billion people and Germany has also only 80 million. So there's a lack of weather stations, and not only that, but half of them are not actually working. So the point is, we need to have more data, but we need to have more data in a low power and sustainable way. And in fact, this comes from Nature of a couple of years ago, when they put some environmental center on seas. I mean in the Arctic, and it's kind of buzzing, right? So you have sensors in the Antarctic, but you don't have sensors measuring water quality in many places. So it's there is a divide in data access as well. So if we're talking about development, there's something which is called SDGs. I don't know if you heard about that. It's 17 goals defined by the United Nations, and they go from no poverty, zero hunger, education, gender equality, water, and so on. And the point about these SDGs is that these goals are supposed to be reached all at the same time. So the United Nations says we cannot only reach one in a specific country. You should try to make sure that you can reach all of them. And of course, it's really hard. So talking about no poverty or zero hunger, those are really hard to achieve. And there's many papers that show how IoT can play an important role in reaching these SDGs. So just if you think about zero hunger, there's many people that don't have enough food. And as we will have more people in the world, in 2050, 9 billion people, we will need to produce more food. And how do you produce more food if you don't have information about agriculture and about irrigation and about food production? So IoT can play a role, just as an example, in SDG 2. And there's many others. again, getting back to climate action, SDG 13, if we don't have enough weather stations, we cannot monitor these famous 1.5 degrees that we're raising the global temperature, because simply we don't have weather stations. So my point in showing these examples is that I think that IoT can play a role in this, reaching SDGs and then in development in general. So that is one goal. So one hat, kind of the UN kind of hat. Then there's the other one, which is the so-called ICT4D. So ICT for development is an academic field. So there's master degrees, there's PhD courses, there's books, there's conferences, it's a complete field where people study how ICT can be used for development. And so if I put my hat as an ICT4D researcher, there is a very famous paper which was published 15 years ago, which is called The Case for Technology in Developing Regions. So what they did in this paper, they analyzed hundreds and hundreds of ICT projects, and they analyzed which ones were successful and which one failed. And the output is that they say there's 4 requirements for these projects to be successful. So one is connectivity. So you should kind of think about projects that don't rely on existing connectivity. Because if you think, again, half of the world is not connected. If you think about, huge countries like Brazil, you will not have connectivity all over the place. And connectivity uses a lot of power. So if you design a project which relies on connectivity, it will not work. It will fail after some time. Second one is low-cost equipment. This, of course, if it has to scale, it has to be low cost. Third one is power resilience. Again, these devices, these projects should not rely on, power sources. And finally, appropriate user interfaces. If you, have worked on IoT projects, you know that it's really nice to set up these devices, but then how do you communicate the result of this, sensing to people that are not technical? So if I, exchange, information with Marcelo, with your community, it's easy. You show graphs, but if you have to communicate about irrigation to someone that is not literate, it will be really hard. You need to think about how to do that. So if you think about IoT, you can actually fulfill all these requirements. You can set up an IoT network, which doesn't require connectivity to the internet. It's low-cost devices, it's low-power devices, and there is no interface. So you need to come up with a new interface so that you have to go through that exercise. So I published some papers where I say that, in my view, IoT is really good for this ICT4D because it fulfills these requirements. So I said that I have been involved in many of these training activities as part of these 3 pillars. And in fact, I organize, it's more than 30 activities all over the place, mostly in Africa, but in Latin America and in Asia as well, and some of them at ICTP. And I learned some lessons from these workshops that I want to share with you, and maybe they could be useful if you plan some IoT project. So this was the first one, which was in 2014. It was about air quality in Benin, which is in West Africa. And the issue there was that there was no air quality sensor in Cotonou. So it's a big city, large city. They have an issue with pollution because people buy fuel in nearby Nigeria, and then they mix fuel with other chemicals. And so it's quite polluted, but there is no air quality sensor. So with the students, we designed some air quality sensors in a kind of quick prototyping exercise. In fact, you see there's a prototype on the top left there. It has some tape, so it looks like a prototype. And we deployed five of them in Cotonou. So we gathered some data, and that even won some, or it was a finalist in some GSM association prize. But the point here was quite interesting. So mobile connectivity wasn't there everywhere. So we planned to use 3G in the city, but actually 3G wasn't available all over the place. So we had to design quickly a system based on SMSs, except that there is no IoT system that uses SMSs. So there is no kind of gateway for SMSs. So we had to design the whole system by scratch because we had to use SMSs. So the point is that mobile connectivity, as we said, it's an issue. You cannot rely on it, all the time. But the main issue was point 2 and point 3, which had to do with openness. So we discussed the project with the government the first day, and they were super excited. And we made the data public. And after a week, they weren't that excited because the air quality wasn't very good. So this kind of discussion about data privacy and openness is kind of key. So it's good to gather data, but then you have to put this data somewhere and you have to decide if the data is open or not. And you have to discuss that with the final users and with the stakeholders. Now things have evolved much more. So now there's many air quality sensors. This is a project that has many, just as an example, in Nairobi, Kenya, and they measure all sorts of things, not only PM2.5, but also humidity and temperature. So things have evolved quite a lot. Second project was in Thailand, so completely different environment and completely different application. So they were interested in IoT for fish farming, which is an application I would have never thought about. I don't know if it is popular in Brazil, but in Thailand it is quite popular. So people have these big kind of pools, and they grow fish inside the pools. And the issue that they wanted to solve is, can you know at the end of the year how many fishes I will have by measuring water conditions? So turbidity, pH, temperature, and redox, so how much oxygen you have in the water. So the goal there was to have a model whereby I could, measure these parameters for 1 year, and at the end of the year say, you're going to have, 1,000 fishes. And so in that kind of application, it is much more difficult because you have sensors in the water, but it was quite challenging. So the most important lesson here is number 2 here, which is about sensors. So people get often excited about sensors, but sensors need maintenance. And especially sensors that you put into water, they need a lot of maintenance. You need to remove the sensor every couple of months. You need to clean the sensors. You need to calibrate them again, and then you put them into the water again. So as much as you can buy these sensors for, a few $100s, so it looks okay, you need to pay someone to do that. And if he doesn't replace the sensors and clean the sensors, you're in trouble. And third one is 2016. This was, I would say, the most successful one, was in Rwanda, so a really small country in Central Africa. And the application they had in mind was T monitoring. So the way it works is that we organize the training, and then we ask to the local organizer, what is the application that would be interesting for you? And so they came up with T monitoring. And so Rwanda is a special place because it is a really small country, and they adopted some special telecommunication rules. So they have 4G all over the country. So connectivity is not an issue, not at all. You can get 4G all over the place. So when they said T monitoring, I was thinking about something which is shown in the upper left. So this is how they have the tea leaves, and I thought it would be useful to monitor how they process the tea. But actually that was not the case. So they were interested in what is shown in the bottom left side, which is a tea factory. So a tea factory, takes the tea, and then the tea gets, fermented. And in the fermentation process, they need to blow some humid air, which is, maybe you can see it, there is a fan in the back there, that blows some humid air, and they need to measure the humidity and they need to measure the temperature. So if the process is done well, they produce high quality tea. If the process is not done in the proper way, they have to sell low quality tea. And it has only to do with the processing. It's not the plant. The plant is the same. And the difference in price is 10 times. So it's really important to get the two parameters, monitored. And the way they used to do it is by this manual thermometer that you see the guy in the right is holding. So they would, every hour they go there and they would measure temperature and humidity. So we replaced that with an IoT device, which was maybe $10 in price, and that could measure the two parameters every few seconds. So in that case, it was a business. This is a private company. So they immediately picked up the idea and they started, deploying these kind of devices all over the company. And in fact, in that case, point two is that the business model is a strong driver because, of course, it makes sense. You invest a few $100s and you make thousands of dollars. But the issue was data ownership. Again, so people from the company said, okay, nice. Where are you going to store the data? On the cloud. Oh, where is the cloud? Is it in the US? Is it in China? Is it in Europe? Is it in Africa? They wanted to know where the data was stored. And again, it's a lesson that I learned. I had no idea that people thought that that was so important. And in fact, I learned that there's only one company, which is Microsoft, which for a low price allows you to store the data in the country. So that is one of their, selling points for the cloud. And that was so successful that then Rwanda, University of Rwanda, applied to become a center of excellence in IoT. They received a grant of $5 million from the World Bank, and now they have PhD courses, they have master courses, very nice labs. So it was really quite successful as a course. Following year, 2017, it was same course in Ethiopia. So in that case, they were interested in car monitoring. So monitoring traffic in Addis Ababa. So using some more advanced IoT devices, using vision. In fact, after that course, we published a couple of papers about doing that with machine learning. But in that case, the key issue was number 2, which is type approval. So it's nice. You read about all these devices on the internet and they look cheap and you can buy them from, I don't know, China or US or Europe, but then you need to import them in the country. And that can be a pain because many countries, rightly doing so, require this type approval. So they want to check what kind of device is that. Is it what kind of spectrum you're using, how much power you're using, and so on and so forth. So that took about 6 months to get the devices in Ethiopia. So type approval of equipment is, again, quite important. And in fact, there were some news about there was Kenya Communication Authority that wants to scrutinize IoT devices before sale, which is kind of difficult, right? So these IoT devices, they have a hardware part, but they also have a software part. So as much as they scrutinize devices, people can change the firmware and they can have devices operating in a different way. So it's kind of a tricky issue. But again, this can be, a game stopper. Same year, we had a workshop in Indonesia and in Mauritius, and it was about 3D printed weather stations. So it was a time where 3D printing was really, there was a big hype. People they were really excited. So we worked with NOAA in the US to produce some 3D printed weather stations. And we deployed them in Indonesia, and we helped deploy them in Mauritius. But in that case, the issue is number 1. So calibration. So as much as these low-cost solutions might seem exciting and interesting, then final users are not happy with uncalibrated devices. They say, okay, you can now develop a weather station which is really cheap, but what about the data? Can I use that data together with high quality data? And the answer is no, of course. So experts say, but that's of no use. So that again is 2017. If you move forward 3 years or 4 years, now it's completely different. Now you can buy low-cost IoT-based weather stations which are calibrated. So technology moved so quickly that now you can buy really low-cost weather stations. So if you're interested in this kind of applications that have global development as a focus, there's a really interesting book which is called Harnessing the Internet of Things for Global Development, produced by Cisco and the ITU, and they cite some of these projects from different organizations, including ICTP. And finally, my last slides are about TinyML. So I understand you learned a lot from Marcelo about TinyML. So you already know about it as a background. And following what I said about IoT and development, if you think about TinyML, I think this is an even more interesting technology than IoT, because we said that there's connectivity issues. Well, in TinyML, you don't need any connectivity, right? You're doing your calculations on the edge, so no connectivity is needed. So we're okay. Low cost of devices, those are low cost devices. Low power devices, those are low power devices. User interface, there is no user interface, and I think this is a kind of a sweet spot in TinyML, right? People need to come up with a way to communicate the results coming from TinyML, devices. So together with Marcelo and with many other colleagues, we set up this TinyML network. So the idea is to create a network where universities work together and exchange ideas and solutions and projects and teasers ideas on TinyML. And so there's I guess 2 universities in Brazil, but I think there's going to be more because we're going to open for other 20 members. And you see there's a number of universities in Latin America, some in Africa and others in Asia. And so, yeah, there's training material available. So there's the 2 courses at UNIFEI that Marcelo organized in Portuguese, but there's others, the EDX course, the workshop that we had a couple of weeks ago at ISTP, there's the Harvard course. So all this is publicly available. And I think that is all from my side. If you have any questions, I will be more than happy to answer.
Oh, fantastic, Marco. Thanks a lot. It's amazing. I didn't know about those kind of projects, and it's really interesting how you got the issues on each one of them, and it's amazing. I didn't thought fully about that, how TinyML can solve them. It will be very, of course, as you said, once we do the job, you need to communicate the results. And LoRa is some technology that can help this a lot, because usually the results are only few bytes. No, it's okay, no okay, you working, not working, or 2 or 3 classes. So this connection, so interesting. I participate once, and people say that the TinyML is like IoT without communication, or offline IoT, or something like. Maybe it's something like that, no?
Absolutely. There's one student in Rwanda, for example, and he developed, I wouldn't say TinyML because it's a Raspberry Pi with a webcam, but it could easily become a TinyML solution. So he put this device on this belt where the T is moving, and he picks up the color. So from the color that the T has, then he alerts people and say, oh, you should put more humidity, or maybe the temperature is too high, or something like that. But again, now he's doing that with a Raspberry Pi connected to the power socket and so on. But it could be easily done with TinyML, and maybe it could be done in different places in the T factory as well.
No, fantastic. People, let's use Marco's experience. Make some questions for him. Okay. Who'll be the first? People are ashamed.
Yeah. But don't be.
Hi, Marco. My name is Marcelo. Nice talk. It's really interesting. And I would like kind of opinion about it, because I recently become a member of a team that develops rockets here at UNIFEI. And my initial idea is to apply some kind of TinyML to kind of monitor its flight, kind of to see if there is some anomaly and things like that. And I think that what do you think about this idea, and what could be the possible problems that may find if I would try to apply it?
Very interesting application. Yeah, sure. I mean, for anomaly detection, I think that would be excellent, right? Maybe one thing to consider is the delay, right? So I don't know if you have used Edge Impulse already. I mean, in the Edge Impulse, you can optimize the model for different parameters, right? And one is delay. So to make the system as responsive as possible. And then how would you send that information down to the Earth?
Right now, we're thinking like kind of a black box that would register the information during the flight. So we would not need a kind of communication during the flight. We would get information later. But if there is some problem during the flight, and I mean, some data would not be recovered. So something that has lower latency and things that get the data and analyze it on the rocket itself, I think it would be interesting to send the data to a black box that we could recover later.
Absolutely, yeah.
Yeah, could be an excellent opportunity for TinyML, because you don't need the communication. You try to solve the problem locally, connected to the physical environmental. That's the rocket itself, no?
Yeah, that's the idea that I have. But I mean, it's just the idea. It's on the beginning. Still thinking about how to do it, especially with the data set. I think it would be difficult in this way.
Marcelo, there was a project that uses a TinyML on a plane, right? A couple of months ago, I think. Was it MIT students or something like that?
No, yeah, they use they use TinyML to see forests, so was in fact was fire detection with the image in small planes, in fact it's in drovers. No? It's Salomon David here has a question. Hey Salomon.
Hey David, how are you?
Ciao Marco, sono bene. Hi. Yeah, it's in English, right? Not in Portuguese.
Yes, it is.
Yeah.
Not yet. I'm sorry.
Yeah. Good night. Yeah, Marco. As you spoken in the early beginning of your talk about the Abdul Salam International Center for Theoretical Physics, this is a multicultural and very international group. Which has people from different places and geographies, and with some similarities when it comes to language and how we interact with technology. I mean, with your experience from the center working with different sets of groups, knowing that here there are many professors who have got many students, how can the center create synergy so that we can bring the set of minds that we're gonna bring to the field of TinyML to start, I mean, co-designing or co-sharing or improving solutions, technologies, or approaches to do research together, knowing that at the end of the day, we all speak, most of us speak Portuguese, and we would like to meet with other groups that you show that they are also working TinyML, because at the end of the day, I mean, this can be a major force to shape this research field. I mean, how can, with your experience and with the activities that the center does, we can come up with different perspectives that will propel the field further than how it has been going presently? Thank you.
Thank you. Very good question. I think it can be done through this activity called a network. So ICTP can support networks. And in fact, I forgot to thank Jose Alberto, that is the focal point for this network in TinyML. And the way these networks work is that ICTP supports them, but ICTP is not an active partner in this network. So the idea is that there, people, universities that are part of this network collaborate and work together. So now in COVID times, it's a bit hard, of course, because everything is only online. But in normal times, networks do have a budget, and with that budget, they can exchange people. In fact, the budget is meant for people to move from one place to another. So my point is that, for example, as you were, citing TinyML, one could think about an activity for Portuguese-speaking researchers that work in TinyML, and that can be funded by this ICTP network, which is already in place, by the way. So that would be the mean to do it, because as David knows, when we organize activities at ICTP, it's really balanced geographically. So we tend to have a third of people from Latin America, a third from Africa, and a third from Asia. And just to give you an example, when we open a course here, we can host about 30 people in the lab because it's physical space, and we usually get 300 to 400 applications. So you can only select 1 out of 10. So it's really competitive. So these networks, I think, can grow in a much more sustainable way. David, I hope that answered your question.
Ivan?
Hi, everyone, and thanks a lot for the information and for the presentation, Marco. I am from an education background, so my questions might not be very technical, but I'm mostly concerned with the impacts and applications of TinyML, IoT, ICT4D in the same context in terms of serving underserved communities or for development of communities in need. So my question is mostly regarding your experience with these projects and how they have this ability or capability to affect change. By that, I mean, just to give you an example, there is this idea in education of kitology. So a company like Arduino creates this kit and creates these prefabricated experiences. Learners go through them and they excel at those experiences. But the moment they are presented with something else, another problem that goes outside that experience that was prepared for them, they struggle, simply because they were not prepared for it. And in a way, it was designed as if that was the main, or as if that was all that there was to it. So what I generally face in my own experience and work is that there is this elevated focus on the tool, on the technology, and not as much as in the skills and problems that the end user is actually going to need to make use of it. So, and this is more a reflection. I'm not really expecting an answer, but it's more like a reflection. But in your experience, how do you feel, or what is there that is being done so that TinyML is not just this new interesting technology, but it's also a driver to affect change in terms of it being meaningful for those that really need?
Ivan, that's an excellent point. And I might, give you an example. When I was doing more kind of Wi-Fi oriented training courses, and there kind of the standard was Cisco academies. I don't know if Cisco academies are popular in Brazil, but they're quite popular in many countries. And that is exactly the kind of training, very controlled training that you get. So you learn how to do things with specific equipment when everything is in place, and it's a very controlled experience. But then when people get to the real world, it's a mess, right? Things are not controlled at all. And if you look at the pictures I showed about this antenna drilling and antenna producing, this is exactly the kind of idea. So flipping the experience completely. So people, when they come to a training, they expect the kind of Cisco training, right? You show some slides, everything is controlled, you know the IP address that you need to give to the devices. But when you give them an oil can, you say, okay, now you should, drill a hole in the oil can. And now we test what is the performance of the antenna, because there is a theory behind that, but you can actually design your own antenna and, experiment with that antenna. It changes the mind completely. So people understand that it is not a black box that you need to use, but you can actually dive into the technology and, learn about how it works and how you can modify it. So I would say that is one point. Then the second point that I found really key in these 30 training activities that I organized, maybe the first half, I had something in mind. So I said, okay, IoT can be useful for agriculture. So I went to a specific country. I said, oh, IoT can be used for agriculture. But people had completely different applications in mind. So then I became much more relaxed. And when I went to some place, I asked them, what is the application that you have in mind? And I can tell you, it's nothing that someone from Italy can imagine. They would have completely different applications. And those applications had an impact on their communities. So starting from that application and building on the application, the theory and the labs and then the deployments was much more successful than coming up with my, application in mind.
Predefined. Okay, that's very interesting. I just have one more question, which is regarding the materials. And I think this is something that even during the course, we discussed it a little bit as well regarding the scarcity of some of the resources, the microcontrollers, the sensors. And I don't think it's different for some other technology related fields, the difference between those who have and have almost everything and then those who don't have and then they have almost nothing. So generally what happens, and in Mozambique, in my country, just having an Arduino board is kind of a luxury. So having an Arduino board, I'm not talking about the kit, I'm not talking about having multiple available sensors. It's still difficult to have the very basic components just to onboard students, just to onboard individuals, and just introduce them to this field of technology where there is this overlap between electronics, programming, and solving problems that are meaningful. But then on the other hand, we have a lot of labs, and I'm talking somehow by experience as well, I've witnessed a lot of over-resourced labs that have literally lots of kids just catching dust. So what I wanted to know is, are there any other plans or projects that in a way try to bridge this gap? And I know that some of these equipment are just thrown, they just become electronic waste, but they are still usable for some other people in some other context. So I wanted to know if in the context of TinyML, since it's something very relevant for those who need, those that don't really have that much, otherwise they could have been using some other equipment. So is there any project or ideas regarding resourcing?
That's a very good question and a very difficult one, to be honest, because I have seen in my experience, as you say, drawers full of equipment, even stuff that we send to countries that are kept there. And then when we go to the country again, say, we have been really good in keeping the equipment safe. I said, no, that was not it was meant to be used, right? Not to be kept safe. Exactly. So my only key there is that as these devices are becoming cheaper and cheaper, in a way it is easier, right? So once, in the old days, you used to have this $500 access point. Now we're talking about a $5 electronic equipment. So maybe that changes things a bit because of the value, really the monetary value of equipment. But as Marcelo knows, I have been pushing a lot this activity to get equipment into hands of people, because I know that even if it's $5, so your university might easily spend $5, right? It's not an issue spending $5, but the kind of administrative issues and the practical issues to get these devices in the countries are a huge overhead on that $5. So with this academic network, we now have the funding, and we in fact bought the devices so that each and every student which is part of the network will receive a kit. And yeah, that hopefully will help. But as you say, it's not easy. I mean, another kind of angle has to do with ownership. So when people own these devices, so it's not owned by the university, it's owned by Ivan, it's owned by single persons, then they feel that they have to use it because it's their own device. So maybe that will change things a bit. I don't know, hopefully. Again, I mean, something that maybe I didn't mention is that my group at ISTP is 2 people. So, these activities, we kind of really, organize the workshop, teach. If we get support, we provide the support, but then it's up to the local teams to, follow up and to make it sustainable.
Okay, thank you.
Yeah, but I wanted to complement the Ivan question. We know that it's a big issue, the components, and each country has their problems to receive components. Besides the problem that we're facing nowadays with the shortage of components. But I think that the goal of our network, the goal of what Marco is leading in ICTP, that we are following in UNIFEI and Instituto Federal de São Paulo, is try to, let's say, okay, we are using a kit with the Arduino is a base to spread the knowledge to everyone, to become easier to have only one platform. So we can talk this in Itajubá, in São Paulo, in Mozambique, in Italy, and everywhere, in Colombia, etc. But of course, this is only a small step. After that, once you have the concept, we must go over that. It's not this is only let's say it's to help us to as a starting point, so we can use other devices. It's a ESP30 trues or other components are RISC-V devices and another platforms, not only TensorFlow, like Micro Pure or Edge Impulse, or can use others. I think our goal, not only Marco or myself here, it's all of us, because we are pioneers. Now, this group that are here together today, we are talking about 30 people here that are together in this second edition of the course. If you put more 20 something from the first one, as José Alberto said today, another day, we're talking about 50 people in Brazil that started that, plus our friends from Mozambique. You have our 2 friends like Ivan and David here. So we have the mission to go further with that. And let me give you the word to João Shinohara from São Paulo, from São José. John is from Federal São Paulo.
Hello, this is Zenaro. Good afternoon. Nice
Hello.
to see you again. Congratulations you and thanks for your presentation or your work. We are very grateful for the activities provided by the working group Tiny Machine Learning. We are in the last month of the Tiny Machine course at FA. Our friend Marcelo, Carlos, Alberto, and many people in Itajubá. The course is very good, enriching, and we are enjoying it a lot. For many of us, there are many needs to solve problems. We hope to continue the actions and collaborate more when we have more control and mastery of the topic. We thank you for your valuable collaboration and the people of UNIFEI that send us the kit to do the experimentation and some projects. And at the end of the year, we are going to talk to how to explain, to change our technology with our same kind of schools in Brazil. We have more than 500 kind of schools in Brazil that we can exchange our knowledge and exchange the kits and some things like this. And thank you very much for your big work. And it's good. Thank you, Marcelo, and Carlos, UNIFEI, Marcos Zenaro. Thank you very much.
No, thank you. Thank you very much. And I think one issue with TinyML is, as in IoT, that you need to have so many different, competencies, right? Because we're talking about data, so you need to know about machine learning. But those are embedded devices, so you need to know about embedded devices. And sometimes you send this data, at least, using LoRa, as Marcelo was saying. So you need to know something about telecommunications and about these new protocols. And maybe you store the data in a database, so you need to know about that and about security and privacy and ethical issues. So I think that is really a challenge, in these new technologies. And that is something that we're still trying to find out how to tackle. Okay.
Well, I think that we have a time for one more question. Stefan have right here a big question for you.
Okay.
It's about a project she's thinking about. Very good. Yeah.
Composition and air. Yes, absolutely. And clean air. Yes. There's a lot of interest right now about CO2 as well. I don't know, Stephanie, if this is something that you are also looking into, but lately in the last couple of months, I have read about many projects about CO2 and about being able to kind of calibrate these CO2 measurements with TinyML. And we have heard about that with Marcelo, right, in the ISTP workshop. So all these sensors are sensitive to temperature and to humidity. So if you only have the sensor, it's really hard to calibrate it because it's difficult to calibrate the measurement with temperature and humidity. But with TinyML, you can do it quite, I wouldn't say easily, but you can do it. And there, Stephanie, comes something that, as Marcelo said, we can do as a network. So we have this colleague from Colombia, from Javeriana University in Bogota, and they have many air quality sensors in Bogota. It's a huge issue, big city, and they have the issue of calibration. So they have seen that after some time, these devices lose their calibration in some way, or they give data which are not reliable. So he was really interested, he's from academia, in using TinyML to study calibration of air quality sensors. So if you're interested in that, in our Discord, a group, we can set up a subgroup working on calibration of sensors. I think it would be really nice. Yeah.
I must tell you, Stephanie is a hard worker. I had a pleasure to work with her the last semester in the course, and wow, I learned a lot with her. And Stephanie, you have a possibility to do this work. We appreciate that. Huh?
Yeah, I think as Marcelo said, we're like pioneers, right? So this is new. So I mean, work using TinyML, even the simple one, I think is really useful. I shared with Marcelo today a paper about quite interesting one about using the sound that is produced by these transformers on the electrical lines. So as you know, these transformers, they produce a really a low frequency sound, and apparently by using that sound you can understand when the transformer is not going to work properly. And if it doesn't work, it's a huge issue, right? Huge issue. So that data set is already available, and the idea is to use IoT to do that. But nowadays we can use TinyML again with a maybe $10 device, really cheap device. We could use that data set and use the sound produced by the transformer. That has a huge application all over the world, I would say.
Yeah. No, the sky is not the limit. That's the reality.
Yes,
Marco,
exactly.
Yeah, I must tell, thank you very much. I know that's very, very late for you and in Europe. But Marco, I would like to thank you in not in name of the both universities here, but in name of all our community. The only reason that you have the TinyML course in the universities in Brazil is because you started that discussion with the Harvard X group, and I started with you at the beginning of the year, and I gave the idea to, I bring the idea to the university, and the fantastic professors here at the UNIFEI took the idea and said, let's do it. So it was very good. It was really, really, really good. And thank you, Marco. He was a kind of a, let's say, good father of our TinyML course here in Brazil.
Super, fantastic. Thank you very much for the invitation, and let's keep in touch. I mean, I really appreciate it. Absolutely. Okay.
I think ICTP in Brazil will grow the relationship, I'm sure.
Absolutely. By the way, that is an opportunity, right? Maybe that, I forgot to say that this visit to ICTP was to have more projects together. So if we have something in mind, I see something in the chat about doing, some courses or some maybe joint PhD students. Drop me an email and we can propose that to this Brazilian embassy in Italy, and they will probably fund it because they want to have more scientific collaborations. So fantastic. I think it's an open opportunity. We should use that.
No, let's use it. People, we have here, half of the people here are professors at the university, and guys, let's do it.
Okay, let me put my email here in the chat. Okay, thank you very much.
Thank you very much.
Let's keep in touch. Thank you. Bye-bye. Bye-bye.
Muito bom.